It actually rains on the sun. Not water, of course, but rain made of plasma. Hot, electrified gas falling from the sky of our star like fiery droplets. And for decades, scientists have struggled to understand how this strange solar rain forms so quickly during solar flares. Now, researchers at the University of Hawaiʻi have finally figured it out, and their discovery could completely change how we predict space weather. When we think of rain, we picture clouds, water vapor, and the cool blue skies of Earth. But on the sun, a massive ball of plasma burning at millions of degrees, things work a little differently. Solar rain happens in the sun's corona, that bright, glowing outer layer you see during a solar eclipse. It's made of superheated gas, or plasma, that can reach temperatures of over 1,000,000 degrees Celsius. And yet, in the middle of that extreme heat, scientists have observed cooler, heavier blobs of plasma suddenly forming, then plunging back down toward the sun's surface, like glowing fireballs. For years, that didn't make sense. How could something cool down so fast in one of the hottest places in the solar system? Old models suggested it should take hours, maybe even days, for that plasma to cool enough to rain. But solar flares, the violent bursts of energy that trigger these rains, only last a few minutes. So the math didn't add up. That mystery has finally been solved by Luke Benovitz, a first-year graduate student at the University of Hawaiʻi Institute for Astronomy, working alongside solar physicist Jeffrey Reep. Their research, published in the Astrophysical journal, offers a brand new explanation, and it all comes down to the sun's chemistry. You see, for decades, solar models assumed something very simple, that the mix of elements in the sun's corona, things like hydrogen, helium, and heavier elements like iron, stayed the same over time. But what Benovitz and Reep found is that these elemental abundances actually change, especially during solar flares. When elements like iron or silicon increase in certain regions, they change how the plasma cools. Iron, for example, radiates heat very efficiently. So when the concentration of iron suddenly goes up, it allows plasma to cool much faster, almost instantly, creating those dense, heavy blobs that fall back toward the sun. That's solar rain. And now, for the first time, the physics behind it actually makes sense. As Benovitz puts it, it's exciting to see that when we allow elements like iron to change with time, the models finally match what we actually observe on the sun. It makes the physics come alive in a way that feels real. This discovery isn't just about understanding the sun. It could change how we predict events that affect life on Earth. Solar flares and coronal mass ejections, massive eruptions of plasma from the sun, can interfere with satellites, power grids, and communication systems. By improving our understanding of how the sun's atmosphere heats and cools, scientists can build better models of solar behavior. That means more accurate forecasts of solar storms, and potentially more protection for our technology here on Earth. Jeffrey Reep, one of the researchers, explained it this way. We can't directly see the heating process on the sun, so we use cooling as a proxy. But if our models haven't treated abundances properly, we've probably been overestimating how long it takes to cool. That means we may need to rethink the way we model coronal heating altogether. In other words, this discovery might send scientists back to the drawing board, but in the best possible way. And here's where things get even more interesting. If the composition of the sun's atmosphere changes over time, that means the sun is far more dynamic than we ever realized. Its outer layers aren't just burning steadily, they're constantly evolving, with shifting chemistry that affects how energy moves through the corona. This could have huge implications for understanding other stars too. If our sun, the star we know best, has a changing atmosphere, then maybe other stars experience similar cycles. It might even help astronomers decode the behavior of distant suns we can only observe through telescopes. So, what started as a mystery about fiery rain on the sun could reshape our entire understanding of stellar physics. It's fascinating to think about. Even after thousands of years of watching the sun rise and set, we're still uncovering its secrets. From the smallest flicker to the mightiest solar flare, the sun is a living laboratory, one that reminds us how much more there is to learn about the universe right above our heads. So yes, it rains on the sun. But now, we finally know why. And with that answer, scientists have taken one more step toward truly understanding the heart of our solar system. If you enjoyed this story and love discoveries like this, hit the like button and subscribe for more cosmic news. Thanks for watching, and until next time, keep looking up.